So today, we're gonna see how do we multiply radicals, which is another way to say square roots, and how to simplify them. Now, let's start with something straightforward. Let's try to multiply these two square roots or these two radicals. Now, the rule is when you multiply two square roots, you need to make sure they have the same root. In this case, there's always an imaginary 2 there if there's nothing there. Since they have the same root, then you can multiply them. That's a rule for radicals. Now, they have the same root, both don't have 2's. So what can we do? We can multiply. Now, the multiplication happens with, you're going to multiply the numbers inside the radical. So the square root of 5 times the square root of 10, that is equal to the square root of 5 times 10, which it simplifies as the square root of 50. Now, this is your final answer, but we need to simplify. Now, for us to simplify a square root, well, right now we're going to see just square roots. But when we talk about just regular square roots, we got to see if the number inside can be written as an exponent, which matches the root. Here our root is 2. Is there a way for us to rewrite that 50 as some number raised to the second? Well, here we have a list of perfect squares. Now, you see that 25, we can rewrite it as 25 times 2. Now, so we can rewrite 50 as 25 times 2, but we see that 25 can be written as 5 to the second. 5 to the second times 2. Now, why do we do this? Because the moment that your exponent matches your root, this 5, you can take it out, which is exactly what we're going to do. So what this is equal to is 5 square root of 2. Now, this is the simplified version of our original. Let's do some more examples here. Okay, so now let's look at example 2. In example 2, we have square root of 6 times square root of 6. Again, they have the same root, which again, if you see nothing there is an imaginary 2. They have the same root, so you can multiply them. So now this becomes 6 times 6 inside the square root, which is equals to the square root of 36. But what is the square root of 36? According to the table, 36 can be written as 6 squared. And again, the moment that your exponent matches your root, they cancel out. So yeah, your final answer is just 6. Okay, let's look at the next example here. Again, all we're doing is just multiplying if they have the same root, which in this case, again, if you see no number there, there's always an imaginary 2 there. Remember that. Oops. So now, what happens here? What happens here is that we need to distribute the square root. So we gotta distribute. Now what happens when you multiply square root times a number? Well, you put the number outside and the square root next to it. So the square root of 3 times 5 is 5 square root of 3 plus, again, when you multiply two radicals, if they have the same root, which in this case they do, square root of 3 times the square root of 3, that's equal to the square root of 9. And then let's see if we can simplify the following. Well, do you know the square root of 9? The square root of 9 is 3. So now we have that 5 square root of 3 plus 3. And that's your final answer because you cannot simplify it any further. Let's try that again. Now, for example, D. Again, if they have the same radical, which they all do, they all have root of 2. There's an imaginary 2 here, 2 here, 2 here. Now we're going to simplify. So let's distribute the square root of 3b times the square root of 6. That's the same as the square root of 3b times 6 plus, we'll simplify again, the square root of 3b times 10. Okay, now we simplify 3b times 6, that's 18b. 3b times 10, that is 30b. Now that we have to this one, let's see if we can rewrite. Let's concentrate on the first radical. Can we rewrite that 18 as a number raised to the second? Well, I know that 19, I can rewrite it as 9 times 2. Why did I choose 9? Because I know that 9, I can rewrite it as 3 to the second. So again, that 18, you can write as 9 times 2. But again, this 9, you can rewrite it as 3 to the second. Okay, now let's look. 30. Can I rewrite 30 as some of my perfect squares? I know that 30, can I rewrite it as 9? 30 divided by 9. Nope. Okay, so 30 I cannot rewrite it. Let's see. No, that's about it. You cannot rewrite 30. So we have 30b. I cannot rewrite 30 as a multiple of any of the following square roots, so I just leave it alone. So now I simplify. When you raise it to second, it cancels out because you gotta remember that there's an imaginary 2 outside. So now we have 3 square root of 2b plus square root of 30. And that's it. You cannot add these two numbers because in order for you to add radicals or terms that have radicals, they need to have the same square root inside. One of them has 2b, the other one has 30b. They're not the same square root, so you cannot add them. Okay? Now, let's move on to something more complicated, which is what happens when we multiply binomials which have square roots. Well, we apply the same rules that we just did previously. So let's distribute this again. So now I have square root negative 2 times, we multiply the insides, 3 times 3, we distribute again. So negative times a negative, that's a positive. When you multiply radicals, you multiply the insides with the insides and the numbers with the numbers. I see that negative 2 is outside, negative 5 is outside, so now that becomes positive 10 square root of 3. So that's the first distribution. When you multiply radicals, you multiply the numbers. Outsides with outsides, insides with insides. So now, let's distribute the 2. So now we have plus 2 square root of 3 minus 10. Now that we have into this form, let's see if I can simplify anything here. Well, I know that 3 times 3, that's 9. And I know that the square root of 9 is equal to 3. So now I have negative 2 times 3 plus 10 square root of 3 plus 2 square root of 3 minus 10. But now, negative 2 times 3, this is just negative 6. Well, let's leave it there so you know what I'm doing. So now it becomes negative 6 plus 10 square root of 3 plus 2 square root of 3 minus 10. So now let's see. Is there anything that we can combine? Is there any like terms? Well, I see that I can combine the two numbers here. So that gives me negative 16. Now, can I combine the square roots? Yes, you can. In this case, you can because you see that both of them have the same square root there. Both of them have the same square root there. Those things I raised to 16 here. Both of them have the same square root there. So both of them have square roots of 3. So what can I do? I can add their coefficients, which in this case is 10 and 2. So 10 square root of 3 plus 2 square root of 3, that becomes 12 square root of 3. And that's our final answer here. Let's try one more example here. Now, let's distribute the following. Again, we want to multiply and follow the rule of radicals. So square root of 5 to square root of 5, that becomes 5 times 5. Distribute again. Plus, multiply the insides. So 5 times 3. I'm done distributing the first one. So let's distribute the second one. So minus 3 times 5. Distribute again. It's a minus 3 times 3. Well, let's rewrite our insides. 5 times 5 is 25. Plus 5 times 3, that's 15. Minus 5 times 3, that's 15. Minus 9. Okay, now let's see. See, do we know the square root of 25? The square root of 25 is 5. Now, why is the square root of 25 5? Because square root of 25, again, this is extra here. Square root of 25, you can rewrite it as, according to a rule, right here. 25, you can rewrite as 5 to the second. Again, the moment that again, there's always an imaginary 2 there. The moment that your exponent matches your root, they cancel out. So now this becomes 5. So that's why I got this 5. So now plus 15 plus square root of 15 minus square root of 15 minus square root of 9, that's 3. So now let's see, can I combine any of these terms? Well, I definitely can combine the numbers here. So now we have 5 minus 3, so that's 2. Now, can I combine the radicals? You see that they have the same radical, the square root of 15, square root of 15, so I can combine them. But they're going to cancel out because it's positive, that's negative. They cancel out. So our final answer here is just 2.